The space race. How war, fear, and rivalry built the road to the moon. The road to the moon did not begin with wonder. It began in ruins. In 1945, Nazi Germany collapsed, but one part of its war machine immediately became a prize for the victors: rockets. The United States and the Soviet Union rushed to seize what remained of Hitler's missile program: engineers, test data, machinery, unfinished weapons. They were not chasing science fiction. They were chasing power. But Germany was not the only source. Soviet engineers and theorists had been working on rocketry before the war. The United States also had its own pre-war work in propulsion, aviation, and military research. What Germany provided was not a beginning from nothing, but a brutal acceleration. In the new world taking shape after World War II, rockets were not just machines. They were weapons with a future. A nation that could build powerful long-range rockets might one day deliver nuclear warheads across continents. Before rockets carried satellites or men, they were built to carry destruction. Then the Soviets began landing blows. Sputnik, the first satellite, a metal sphere beeping over American heads from orbit. Laika, the first living creature sent into space. Then Yuri Gagarin, the first man to leave Earth. Each success hit harder than the last. In the United States, this was not just embarrassment. It was fear. Fear that Moscow was moving faster. Fear that Soviet rockets were stronger. Fear that the balance of power in the Cold War might be shifting overhead. That was the real birth of the space race. Not a peaceful contest between dreamers, but a struggle between rival superpowers, each trying to prove that its technology and its system would shape the future. That is why this history matters now. As America returns to the moon with Artemis, it is moving back onto ground first claimed by war, rivalry, and the struggle for power. The United States and the Soviet Union did not build their rocket programs the same way. America had money, industry, universities, military branches, laboratories, and private contractors on a scale the Soviet Union could not match. But that strength came with friction. Work was spread across many institutions. Priorities competed. No single hand controlled everything from the start. The Soviet Union was tighter, harsher, and more secretive. Its leaders could force resources into one program, shield it from public scrutiny, and demand quick results. That helped in a race for dramatic firsts. But the Soviet model had costs. Projects were hidden. Rivalries were buried inside the bureaucracy. Fear ran through the system. Failure could be punished, not just corrected. Sergei Korolev stood at the center of that world. He became the chief architect of early Soviet space success. Before that, Stalin's state had arrested him, beaten him, and thrown him into the Gulag system. Later, that same state pulled him back into high-level technical work and demanded results. That was one brutal fact behind Soviet success. The system could destroy talented people and still expect them to build the future. Even so, in the first phase of the Cold War rocket race, the Soviets moved first and hit hard. Their rocket power was real, their launches were real, and they knew how to turn technical success into a political weapon. Then came Sputnik. On October 4, 1957, the Soviet Union put the first artificial satellite into orbit. It was a small metal sphere with radio transmitters. But nobody cared that it was small. What mattered was that it was overhead. Americans could hear it. That made the shock worse. Sputnik was not just a newspaper story. It was a Soviet object circling above the United States, beeping through the sky, carried there by a rocket powerful enough to frighten Washington. The alarm was immediate. If the Soviets could throw a satellite over the world, they might be able to throw nuclear warheads over the world too. Sputnik turned rockets from a technical subject into a public national problem. And the blows kept coming. Laika. Then Yuri Gagarin. One Soviet first after another. Each success made Moscow look bolder and faster. Each one made the United States look flat-footed. It was not just a matter of science. It was a matter of who seemed to control the future. Washington answered the shock with reorganization. In 1958, the United States created NASA. That did not separate space from military rocketry. The same engines, guidance systems, Staging methods, control systems, materials, and test practices mattered in both worlds. But NASA gave the United States a national vehicle for the contest. America was no longer stumbling from one Soviet surprise to the next. It was building a larger answer. Moscow used its space victories to argue that socialism could outpace capitalism in the most advanced technologies on Earth. Washington answered that a wealthy, industrial, competitive society could recover from setbacks and outbuild its rival in the long run. The argument was no longer only about who could put something into orbit first. It was about which kind of state could organize science, industry, money, and power more effectively. The Soviets won many of the early firsts because early firsts reward speed, concentration, secrecy, and the ability to push everything toward one visible breakthrough. The moon was different. A moon landing could not be won by one dramatic push alone. It demanded years of stable management, giant budgets, broad industrial coordination, repeated testing, and the ability to survive failure without losing the whole program. That kind of contest favored the United States. The moon gave the race a clear finish line. A satellite could be answered by another satellite. A man in orbit could be answered by another man in orbit. But a human landing on the moon was too large to shrug off, too visible, too final. No rival could dismiss it as a minor technical step. That was why the moon became the prize. Apollo was the American answer to the first decade of Soviet blows. It was an exploration program, yes, but it was also a Cold War project built for scale. The United States chose a contest so large, so expensive, and so technically demanding that industrial depth, money, management, and endurance would matter more than a quick string of headline victories. That was America's stronger ground. The Soviet Union did not stand aside. It had its own lunar plans, its own designers, and its own answer to Apollo. But the closer the race moved toward the moon, the more the Soviet system began to show strain. This was no longer a contest for one quick headline. A lunar landing demanded one huge machine built out of many smaller ones. Engines, boosters, guidance, testing, manufacturing, leadership, and political patience. That was where the trouble began. The Soviet effort was fragmented. Authority was divided. Rival design bureaus competed instead of working as one. Secrecy made coordination harder, not easier. Failures could be hidden or delayed, but they could not be engineered away. Technical problems piled up. Time was lost. Pressure grew. The system that had produced early triumphs now had to deliver something bigger, heavier, and far harder to hold together. The Soviet Union had been first into space, but the moon exposed the limits of a system that could strike fast, yet struggle to sustain one vast, integrated effort over time. By the time Apollo drove toward the moon, the race had changed shape. The Soviets had opened the space age. The Americans were aiming at the one achievement that would overshadow everything that came before it. Then, in July 1969, Apollo 11 landed on the moon. That was more than a scientific success. It was the hardest visible target in the first space age, and the United States reached it first. The Soviets could still point to Sputnik, Laika, Gagarin, and the long list of early firsts. Those achievements remained real. But Apollo 11 changed the story people told about the race. America had taken the shock, rebuilt, mobilized, and won at the point where the world was watching most closely. After Apollo 11, the original form of the space race began to cool. Space still mattered for military surveillance, communications, science, technology, and national status. But the clearest prize had already been taken. Once the United States had reached the moon first, the earlier pattern of direct competition for dramatic firsts lost much of its force. The contest did not end, but it changed shape. That is why Artemis belongs at both the beginning and the end of this story. Artemis is not a simple replay of the Cold War. The players are different, the tools are different, and the world is more crowded. But the moon has become important again for reasons that are not purely scientific. It is once again a test of reach, endurance, technology, organization, and national will. And the United States is not moving alone. China is pushing outward. Russia still tries to remain part of the picture. The language is different now. The alliances are different. The hardware is different. But the deeper logic is familiar. The moon is once again becoming a place where power, technology, and national ambition meet. The first space age was not born from pure curiosity. It came out of war, rocket laboratories, bomb calculations, state ambition, ideological struggle, and fear of falling behind. The Soviet Union seized the early initiative. The United States answered with a larger and more sustained mobilization. The moon became the decisive test, and Apollo became the Cold War answer. Now, Artemis shows that the story did not end in 1969. The return to the moon is not just a new chapter. It is the return of an old question. Who will shape the next age beyond Earth?